say this head bigger than your duku. Stubborn academy, we like to shoot too. One bullet I say chale, it go make you poo poo. On a bicycle, so take your trailer. And I'll be famous like Mali and the Whalers. I know they kiss us, fuck all your favors. Nobody bigger than God, Jehovah.
Right, hello everyone, welcome to today's class. So today we have question on dimension in physics. So we'll be solving this set of questions. We want to find the dimension of the following: surface tension, velocity gradient, energy density, moment of inertia, stress, and gravitational constant. So let's see how we can get the dimension of each of them. Now, the surface tension, we are going to start by writing the formula for each of these physical quantities. So before we get the dimension, we want to know the formula first, then we can now calculate for the dimension. Now, the surface tension is giving us force per unit length. So this is the formula for surface tension. So that means if I want to get the dimension, I need to know the dimension for force and the dimension for length. So where we have that dimension for force is giving us mLt raised to power minus 2, and dimension for length is giving us what? As L. So here you can see that the length can cancel out the length. So what we'll be left with is mt raised to power minus what? 2. So that means the dimension for surface tension is giving us mt raised to power minus 2. Now let's do the next one. Here we have for velocity gradient. Now what's the formula for velocity gradient? Velocity gradient is given as velocity all over what? Length. So that's the formula for velocity gradient. So now we have the dimension for velocity as Lt raised to power minus 1 all over. The dimension for length is what? Is L. So you can see that L will cancel out what? L. And we are left with T raised to power minus 1. So that means the dimension for velocity gradient is T raised to power minus 1. Now what is the dimension for energy density? Remember, we're going to write the formula for energy density. So what is energy density? It's simply energy all over what? Volume. So that is the energy what? Density. Energy all over volume. So what is the dimension for energy? Energy is dimension as ml squared t minus all over. The dimension for volume is L raised to power what? 3. So with this, we can be able to see that L squared and L raised to power 3 can cancel out. So this will cancel out this one. So two of these cancel out this. So one will remain. So what we have left now is mt raised to power minus 2 all over L raised to power 1. So now this L raised to power 1 can come up here. So once it comes up, we have ml raised to power minus 1 t raised to power minus 2. So that gives us the dimension for energy density. Now we also have the dimension for moment of inertia to look for. So what is our moment of inertia? So moment of inertia is given as mass times distance squared. So which the dimension for mass is given as m, and distance is dimension as what? As L. And we have a square here. So that means the dimension for moment of inertia is ml squared. Now the dimension for stress. So what is the formula for stress? Stress is given as force all over area. So that's our stress. Now we have the dimension for force as ml t raised to power minus 2, and the dimension for area is L squared. Now you can see that we have one of the L here and 2 here. So this, we cancel one of these. Then what we'll be having is m t raised to power minus 2 all over what? L raised to power 1. Now I want to bring the L up. This will be m, L, it will change to minus 1, then t raised to power minus 2. So that gives us the dimension for what? For stress. Now the next one is the gravitational constant. So for the gravitational constant, we have that force is given as the gravitational constant times the product of the masses all over the distance word squared. So now what we are going to do here is to make the gravitational constant the subject formula. So we move this over to this place. We'll be having F times rho squared all over m squared, or m times m, which will give us the gravitational constant. So with this, I can be able to find the dimension of the gravitational constant. So from here, our gravitational constant is the force. So that means dimension for force is given as m L t raised to power minus 2. Then dimension for the distance is L, and we have it squared, so we square it. Then divide by, we have dimension for the masses, we have m, and the other one we also have what? M. So here you can see that m can cancel one of these m, so we'll be having L with times with L, so we have L cubed, then t raised to power minus 2 all over what? M. Now we want to bring m up so that we have m raised to power minus 1, so the positive changes to negative. Then we have L raised to power 3 and t raised to power minus what? 2. So that gives us the dimension for what? Gravitational what? Constant. So this is how we find dimension for other quantities. So I'll give you an assignment. Try to do this and post on the comment section the dimension for strain, dimension for velocity ratio, and also the dimension for mechanical advantage. So find the dimension for this quantity and let us know in the comment section. Thank you.